So this is kind of to make sure you understand conceptually what we've been talking about. It says describe the region in R3. R3 is another name for space, right? So y equals 5. What does y equal 5? What does that graph to be, first of all? So when I say describe the region, describe the collection of points represented by y equals 5. It graphs to be a certain kind of surface. What kind of surface is it going to be? A plane, right? No, not a sphere. Y equals 5 is a plane. It's a lot like x. I think we graphed x equals 4 earlier. That was a plane, right? Now, x equals 4, if you recall, let's go back and look at that graph. X equals 4, it was this guy in red right here, was a plane that was parallel to what coordinate plane? It was parallel to the YZ plane, right? And how far from that plane is it? 4 units. 4 units. So that would be, we could use that idea, that description, well, change that description enough and use it for that problem below. So adjust that description for this problem. So this is also a plane. This is a plane. I'll say a plane parallel to what? It's got to be parallel. When there's only one letter describing it, it's going to be parallel to the coordinate plane defined by the other 2 letters. Does that make sense? So it's a parallel plane. It's a plane parallel to the XZ plane. And how far from that XZ plane is it? And 5 units from it. 5 units, 5 positive units from it, just to be specific, right? Because I suppose you could confuse that description with y equals -5 if I hadn't put 5 positive units. All right, describe the region in R3. So x squared plus y squared plus z squared is less than or equal to 9. So what was the trick in working with inequalities oftentimes in other classes? What do you replace the inequality with? Equal. So what does the object look like if it's strictly equal to?
Sphere on the origin, radius 3.
Yeah. Does everybody see that? The center is 0, 0, 0, right? The origin in R3. So it's got to be, and it has the form of a sphere, so it's got to be a sphere. R squared is 9, so R has to be 3. It's got to be a sphere centered around the origin with radius 3. So what is the less than or equal to going to do? It's going to make it a solid ball, right? Yeah. So it's going to be the sphere and its inside. Yeah? Okay. So how would we describe it? Okay, I like that. A solid sphere. So better put the center down, right? Okay, so centered at 0 at the origin, let's say. 0, 0, 0, though, if you write it in ordered triple form. At the origin with radius 3. Okay, so when we say solid, we mean the sphere, the surface, and its interior, right? Now, is there any question as to why it's the interior and not the exterior? Is there any way that's exactly right. Now, you could use a test point to verify it. Take any point inside that radius, and you'll get a true statement, right? The sphere itself is kind of the boundary between the points that satisfy the inequality and the points that don't, right? If you take any point inside the sphere, it will satisfy the inequality. If you take any point outside the sphere and plug it in for x, y, and z, plug in those values, it won't satisfy. Here's one that'll test your three-dimensional thinking a little bit. Part C, remember, we're wanting to describe what the set of points is going to be in R3. So what would the set of points look like? The intersection of the sphere of radius √7 with center 6, 5, -2, and the xy plane. So we want to take the sphere, imagine a nice little ball, sphere, and intersecting it with the xy plane. The xy plane is just, the xy plane has the equation z equals 0. It's just a horizontal plane. So imagine taking the ball and maybe a good analogy would be if you had a really calm pond, the top layer of water would be a plane, wouldn't it? And then you dipped a soccer ball. You'd have to hold it down because it'd want to float. You dip the soccer ball into the water. What would the intersection look like of the ball, which is the sphere, and the top of the water? What would that look like? Be a circle. Does everybody see that? So how can we figure out exactly the equation of this circle of intersection? Well, somebody already said it. What's the value of z at the xy plane? So keep that in mind, and now give me the equation of the sphere. So, okay, so write down the standard equation, x minus h squared Okay, so there's the standard form, right? Just plug and chug. So somebody already said it. What did you say? X minus 6 quantity squared plus y minus 5 quantity squared plus z. Well, I want to. We'll get there. We'll get there. It's plus z minus what? Okay, so z plus 2 minus a negative 2. Yeah. Equals 7. Everybody with me on that? Now that's the sphere. So how do we get the intersection curve? So we're going to plug in z equals 0 there. Now, it's still going to be in R3, but it's going to be a circle in R3 so that the z coordinate of every point of the circle is 0. But I'll talk about that in a second. So we get x minus 6 quantity squared plus y minus 5 quantity squared plus what? If we plug in 0 plus 2 squared, or 4, equals 7. And again, this is with the assumption that z equals 0. Okay, and then what does that break down to if we get the 4 to the other side? Yeah, so all this fun stuff equals 3. So then we get x minus 6 quantity squared plus y minus 5 quantity squared equals 3 as our intersection curve, with the understanding that that's happening at z equals 0, right? So we're in space here. If you were told that you're just in the plane, then you wouldn't, in the xy plane, then you could throw out the z equals 0. But we're trying to, the directions did say consider R3, right? Okay, so describe that object to me. It's a circle. A circle centered at, yeah, if it did say R3, so we better put in that third coordinate. A circle centered at 6, 5, and then of course z equals 0 if we're in R3, with radius rad 3.
Should you say that it's parallel to the xy plane?
You could say, I wouldn't say it that way, but if you want to be very specific, I would say it's in the xy plane. Yeah. So a circle, and so to honor your statement, we'll say in the xy plane. Now, some people might argue, well, you intersected it with the xy plane, so you intersected the sphere with the xy plane. It's got to be in the xy plane. So if you left the part in red out, yeah, I'd be flexible about that. Right, so that's an important point. Anytime you intersect two surfaces, or a surface with a plane, that intersection curve has got to lie on that plane, no matter what.